guys, so here we are, day 2 of transformations. We are going to flip to this page right here and get started. So it states the function y equals f of x with the domain of -3 is less than x is less than or equal to 3. This is less than or equal to 2 is provided. So my domain goes from -3 to +3. Graph each of the following transformations, adjust the domain when necessary, and state the domain and range for my transformations. That squeaky noise is my dog. Alright, so if you look here in this, you're going to notice that your domain is -3x 3, which can also be written as -3, 3. My range in this situation starts at 0 and goes up to 3. So this is important because we're going to see how this changes as we transform this, this little V shape. Okay, so in our first situation, we are moving this function. And the thing is that right now, this is actually the absolute value function. So this is actually f of x equals the absolute value of x. Okay. But the reality of it is it doesn't matter what function this is. This applies to everything, which is why this is written this way. But so we're talking about the absolute value. So if we look at this and we say, okay, what would be our table if we threw in, and this was y equals, and if I know it's the absolute value, the function of x, which is x minus 2, I'm going to plug this whole thing in for x, so the absolute value of x minus 2. So what I want to know is, how does this -2 affect this graph? What happens to the graph? And hopefully you remember from Algebra 1, that you basically, when you have something like this, it's going to move to the right 2 units. But let's just see. So if we say, let's just start our domain with -3, just because we know that that's where this point is. When x is -3, -3 minus 2 is going to give you -5. The absolute value of -5 is +5. What about -2? -2 minus 2 is -4. Absolute value of -4 is +4. 1 is going to be 3. 0 will be 2. +1 will be 1. 2 will be 0. 3 will be 1. 4 will be 2. And 5 will be 3. So if I graph this, and I'll tell you why I went that high to begin with, I'm going to notice that here are these points. Coming on down like this. And what I notice is this has 1, 2, 3. So I want my V to have 1, 2, 3. So it's going to stop here because I'm trying to mimic this V right here. And it has 1, 2, 3. So I'm going to go over 1, 2, 3. And so it's going to stop right here. And you're going to notice that this is this same equation, except for now I've got this -2. Okay. And basically what's happened is it's shifted, translated to the right by 2. Okay? Now, when I look at my domain has also then shifted from -3 to -1, 5. Do you guys see that? So my domain is right here. This right here is my domain. and it goes from -1 to 5. My range has stayed the same from 0 to 3. Okay? So if you notice, my original domain was -3, 3. What happened between here and here? Well, I added 2. Isn't that interesting? I added 2. It shifted to the right 2. I've added 2. So -3 plus 2 is -1. +3 plus 2 is 5. Well, let's see if that holds true as we continue on. So this is going to be y equals the absolute value of x plus 1. And we're going to create our graph, our table. And I'm going to use -3, and that would give me -2, which then absolute value of that would be 2. -2 would be an absolute value of -1. 1, -1 would be 0. Then 0 would be 1. +1 would give me 2. 2 would give me 3. And 3 would give me 4. So let's see what that looks like in this graph. So -3, 2. -2, 1. -1, 0. 0. 1. 2. 3. And 4. Now, I've noticed that this only goes 1, 2. This goes 3 to the left, so I need another value here. So I need to figure out what is x when it is -4. Well, that would be then 3. Because I want my graphs to look exactly the same as the original graph. I want this to look exactly the same as this. And so it's moved, the vertex is moved from 0 to 1. It's shifted to the left 1, going into the negative number. So if I'm looking at my domain now is -4 to 2. And my range is still 0 to 3. So when I look at this compared to this, I notice that I've subtracted 1 from the domain. -3 minus 1 is 4. 3 minus 1 is 2. So just keep in mind that you added 2 to the x values or domain, and here you added, you subtracted, hopefully you guys were screaming at the computer, Mrs. About subtraction. You subtracted 1 from the x values. The y's stay the same because it has not shifted up or down. It's just shifted left and right. Okay, so this is a way that you can actually tell what the domain's going to be without graphing it. Now we've got this. This is going to be, if I do my table, we've got -3, and this, of course, equation is going to be y equals the absolute value of x minus 1. So my function is inside, my change of the function is outside. How does that affect? Well, this is going to be the absolute value of -3 is +3 minus 1 is going to give you 2. 2 is going to give me 1. -1 is going to give me 0. 0 is going to give me -1. This is going to give me 1 minus 1 is 0. This is going to give me 2, 1, 3, 2, 4, 3. All right, so let's now graph this. So I look at this, -3, 2, -2, 1, -1, 0, 0, -1, 1, 0, 2, 1, 3, 2, but I'm getting a little bit ahead of myself because I only want it to go 3. 1, 2, 3. I want it to stop here. 1, 2, 3. So it's going to stop there. It's not going to go any further. And so I have to look at my domain. My domain is going to be from -3 to +3. Well, that is the same as the original function. That's the same up here. Let me pull that down a little bit. What about my range? Now keep in mind this has shifted down. Well, what happened to my range? Well, my range now is -1 to 2. And if you notice, I'm subtracting, my original range was 0, 3, I'm subtracting 1. So I've subtracted 1 from the y values. So when the change was inside the function, it was a change to the domain because it shifted it left and right. When the change was to the outside of the function, now it's shifting it up and down, and we're changing our range. So let's see, that should go again. I'm going to have you stop the video and see if you can do this one on your own and if we get the same. Alright, so I have the same shape of the V. Here is my table. I've got my domain is -3 to +3, so that has not changed at all because it has not shifted left or right. But my range has gone up 2, so it is now 2, 5. And if you notice, this has a +2 here, and I'm adding +2 to the y values. Okay? Because if I take my original range, 0 + 2 is 2. 2 + 3 is 5. Okay, so hopefully you're getting that. Moving on. So let's see. So here's the original function again, just on this page, which is nice. What happens? Let's see if you can create the graphs tables for these. So this would be basically y equals negative absolute value. See if you can create the graph for that, or the table for that. So here you've got your table, here you've got your graph. My domain is going to now be the same, which is -3, 3. My range, however, has changed to basically -3, 0. And if you remember, my original domain was -3, 3. And my original range was 0, -3. So these have now just flipped. Boop. They flipped. All right. So just keep that in mind. This is a reflection over the x-axis. All right. Now we're looking at these shifts, these stretches. So we've got f of 2x. So again, go ahead and create your table. This would be the same as y equals 2, the absolute value of 2x. So hopefully you were able to get this table and this graph. This is a horizontal compression because it is horizontally going away from the horizontal axis. But you'll notice, okay, that our domain, again, is -3, 3, so our domain has not changed. But our range now is 0 is the lowest, and 6 is the highest. And if you notice this 2, if you multiply 2 times 3, you're going to get 6. So you multiply the y value in the range by, in this case, 2, whatever this number would be. In this case, it was 2. All right. What about this? Is that going to be the same thing? Is that going to be work? So if you were to use that same logic, you would think that, okay, if I am using the same logic, then I'm going to predict that my domain is going to stay the same. And my range is going to be what? Well, I think my range is going to be 0, and then I'm going to multiply 3 by 1/2. So I'm going to predict that my range is going to be this. And let's go ahead, pause the video, do the math, do the table, draw the graph, and let's see if my prediction comes true. And just as a reminder, this is going to be y equals the absolute value of 1/2 x. All right, so then we're plugging in -3 into this. All right, so go ahead. So here we go, and we've got, this is our graph. We notice our domain is the same, nothing has changed. And our range originally was 0, -3. And then we went ahead and multiplied by, 0, -3. And we multiplied by 1/2, the absolute value of 1/2. And lo and behold, it's the same. So, you know, I screwed that up. This is actually 0, +3. Oh. 0, +3. So that is 3 times 1/2 is going to give you 3/2. So just like over here, when our range, we multiplied the range by 2 and got 6. Now we're multiplying the range by 1/2 and we're getting 3/2. All right? And you'll find that these actually are the same. They're just labeled differently. This one's going to be your vertical stretch. And this is going to be your vertical compression. The graphs are exactly the same. The difference is that this number is on the outside of the function. This number is on the inside of the function. That's the difference between a horizontal and a vertical. This is going to be a horizontal stretch, and this is a vertical compression. Okay, and I'm just going to pause the video and I'll graph these and then you can compare them, or go ahead and try and graph. Alright, so then there you see that, and I didn't graph this. It's going to be the exact same. That looks just like this. So, and you'll notice that the domain and the range are the same because in this situation they're similar. It won't always be similar, so don't think it's always similar. It just is for these graphs. So, okay guys, that's it for this video. Hope that is helpful.